This is the 22nd video of the lecture series Optimization using Excel, and in this video we are going to discuss traveling salesman problem once again. Remember, we already discussed this problem in our video number 18, but in that time we used integer programming as the method of solution. Now in this case, in this video, we will rather use non-linear programming approach in order to solve this problem and try to see the benefits and disadvantages. And of course, since this is a non-smooth type of problem, we will use the evolutionary solver. So as you can see, I have taken the same problem. Let me state the problem once again, just very brief. There is a school bus that starts from a particular school, which is your node 0, and then there are other 4 nodes. These are the node numbers, and the school bus is supposed to visit all these 4 nodes and again come back to the school. So that is the entire route to be followed, and the question is, what is the sequence of this node so the bus should visit, and so that the total distance is minimized. In the last video also, that is in video number 18, we already discussed the pros and cons of integer programming versus the non-linear models. So the main advantage of the integer programming process was it gives us a global optimal solution, whereas for non-linear program it is not possible to guarantee global optimal solution. Also, I have mentioned another advantage here, that is, if you formulate using integer programming, the formulation may be too complex as it is written here, but the solution is faster. That means once you formulate, then the solution happens very fast. But in this case, the reverse is true. That means the formulation is not very complicated. It is very simple to formulate or set up, but the solution takes time. So as we have seen earlier also, the evolutionary solver takes more time compared to the GRG nonlinear and also simplex LP, and hence since we are using evolutionary solver to solve this problem, it will definitely take more time compared to the integer programming approach. So let us see how to solve this problem using nonlinear programming. So come to the Excel sheet. So this is our Excel sheet. As you can see, the first portion is your data, where this particular table is replicated. Only the difference is, in this case, the table has been transposed in order to form a bidirectional table. That means the distances shown in the original table was in one side direction from school towards the other nodes, and now I have replicated those distances or taken the transpose of them so that the table is filled from both the sides. And of course, I have assumed that in both the directions the distances are the same. It may so happen that the distances may be different, like for example 0 to 1 is 6 and 1 to 0 is also 6, but in actual reality it may be something else also, like for 0 to 1 it can be 6, or from 1 to 0 it can be 4. That is also possible, and the solution will not change, or the formulation here will not change because of that. So anyway, I have kept this symmetrical, so there is no point in discussing that. Anyway, so now this is the model which I have kept blank intentionally. Now I will formulate in front of you. So this is the decision variable. This is the decision variable where the node numbers will be populated once the solver runs. And as you can see, this is written in a from to structure. So as we know that the initial node is 0, and whatever route it takes doesn't matter, the final node is also 0. So therefore we can at least say that the initial node is 0 and the final node is also 0. So type it down. This is 0, this is 0. No formula is required for these two entries. Now consider this entry. This is the next step. So from node 0 it is coming to some node, we don't know yet, we'll get to know once the solver runs. But the next, what should be the next from node? It should be the previous two node. So for example, if it is 1, then it must be equal to 1. So it is going from 0 to 1, then it must be starting the next journey from 1. So that means the formula should be equal to this. So the previous two should be the current from. In this way, you replicate all and delete this, of course. So now this part is complete. Now the distance. Now we need to pick the distance from this data set. So we are going to use the index function once again. So index, what is the first argument is the array. So what is the array? Array is the distance array, that is this particular range B3 to F7. Don't forget to press F4 so that this range can be so the range is your entire data, the distance matrix, and then don't forget to press F4 in order to fix it so that it can be copied downwards. Now what is the row number? Row number is, see, suppose this is 2 and we want to go from 0 to 2. So we want this 29 to be populated or to be computed here in the distance. So what we will do, we will pick this particular row and this particular column. What is the row number here? Row number is 1. And what is the column number? Column number is 3. So check very carefully that the node number plus 1 is the row number. So this is the row number 1. So since we have started from node 0, so you have to add plus 1 to the node numbers in order to get the row number. Okay. Similarly, you have to add 1 to the node number in order to get the column numbers. So let us do that. So if I add this from node plus 1, this becomes our row number. That is the first row. From the first row we are picking. And if we add 1 with this 2 node, note carefully, B12 is the 2 node here. So if you are finding problem, let me type it once again here. So index array is your data, fix it, then comma, then the from node number plus 1, and then the to node number plus 1. This completes your distance matrix. You should really contemplate on this once again. First of all, the range is B3 to F7, that is the total data, entire data, and then A12 plus 1. Why plus 1? Because I have a from node 0, but there is no 0 row. Row is starting from number 1, but number 1 entry is 0, so I have to add 1 here. Similarly, for 2 node also, I don't have any 0 node, any 0 column number, it starts from column number 1. So if it is 0 node, then I have to add 1. So this completes my formula. I will enter and I will replicate this until the end. And so what is the total distance? It is simply the sum of these distances. So see, now this is the complete formulation. So it is so simplistic and so easy to implement in case of nonlinear programming, as you can see here. Now the solver input is also easy. Go to data solver and then make this total as your objective function, which has to be minimized because this is the total distance. And what are the changeable cells? These are the changeable cells, which are the decision variables I have already mentioned. And what are the constraints? Constraint is there is no constraint, only one constraint is there, which is the all different constraint. So if I include this constraint, this means automatically they are integers. You don't have to declare it separately. All different declaration itself implies that it is these numbers are integers, and also it starts from 1, that is also ensured. And so make sure that you have selected evolutionary and then solve. So of course it will take some more time, as we have already mentioned that compared to the simplex LP and GRG nonlinear, this particular method evolutionary takes more time. So it is taking more time. There is no surprise. So let us wait. If you are not interested in waiting, please fast forward the video. Otherwise, you can check how the sub problems are getting developed. And interestingly, your incumbent, that means the best solution found so far, is 56, and it is moving around 56 only. There is not much improvement observed here. So our best guess is it will terminate or converge in objective cell equal to 56 only. Let us see what happens. By the way, in our integer programming setup also we found that the answer was 56. So see here, we got 56 as our total minimum distance. And what is the root? Root is 04321. So it starts from 0, it comes to 4, then goes to 3, then 2, then 1, and finally again 0. So this is the root it is saying, which is perfectly alright, because if you check our previous solution using integer programming, then we got the same solution there also. You can see this is the same solution, only the path is reversed. Like in this solution, it was saying that 0 1 2 3 4 0, this was the path, and in this solution it is saying it is 0 4 3 2 1 0. Basically it is the same thing. So this is how a nonlinear traveling salesman problem should be solved using evolutionary solver in Excel. And you must appreciate the fact that the formulation was really typically very easy compared to your integer programming formulation. You can see here the integer programming formulation was too cumbersome and only for 5 nodes, and if it were like 10 nodes or 20 nodes, then it was simply impossible to formulate in this way. But for 10 or 20 nodes, you can just insert rows here and replicate this formulation very easily, and within a minute it can be made ready. So that's all about this video, and hope you have understood the formulation and the method of solution. And let us meet together in the next video, which is going to be the ending video of the lecture series optimization using Excel. Thank you so much for watching this video with me.